Alright, our objective says I will be able to graph relationships using tables, continuous and discontinuous relationships. So basically, first off, mark through these directions because those should not be there. Basically what we are doing today is we are looking at how graphs can represent real life situations. Something like this, a beach trip. What this graph right here does is it relates time and distance. So it's saying this person took a trip to the beach, and as they went to the beach, their distance from home increased. As they were driving there, they got further and further away from home. Then while they were at the beach, their distance from home stayed the same. Then as they returned, their distance from home got shorter and shorter and shorter all the way until they got home right at this point right here. So that's just an example of a graph that represents a real life situation. Here is another example of a graph. This graph shows the various speeds at which a horse travels. Use this graph to complete the table and describe the horse's speed as increasing, no change, or decreasing. So we're going to use those three words. So here's the table. First thing we've got to do is extend it so that we can fill it in. Try to draw it straighter than I'm drawing. So we're extending this table. Draw us a line right here to separate this. This will be my description. So what we need to do is we need to look back at this graph, and based on what we see in this graph, fill in this table. So what's happening from 0 to 10 minutes? We'll look at this part. From 0 to 10 minutes, the speed is, it starts at 5 miles per hour and it stays at 5 miles per hour. So there is no change. So no change, okay? Then from 18 to 20 minutes, what we see is that the speed increases drastically. It goes from 5 miles per hour all the way up to, what is that, 25 miles per hour. So the speed is increasing, okay? Then from 18 to 38 minutes, what happens? Well, it stays horizontal. It stays exactly the same. It stays at 25. So again, in that interval, there is no change. Then from 38 to 40, what you see is this graph goes straight down. It goes from 25 all the way down to 5, so at that interval the graph is decreasing. Alright, lastly, from 40 to 50 minutes, your graph stays horizontal. It stays right at 5 miles per hour, so the last interval there is no change. There is no change. So it goes from no change to increasing, no change to decreasing, no change. That's exactly what happens here. No change, increasing, no change, decreasing, no change. Part 2 says, customers at a local grocery store pay $3 per pound for pecans. They can purchase the pecans in fractions of a pound. Should the graph representing this situation display negative values for pounds of pecans? No. Can you have negative values of pounds? No, you cannot. So a negative number of pounds does not make sense. A negative number of pounds does not make sense. You cannot have negative pounds. Part 2 says, what is a reasonable maximum number of pounds to graph? This says customers at a local grocery store pay $3 per pound. So think about people going into a grocery store. Not like a company buying things from Walmart, but people going into a grocery store. What's a maximum amount of pounds that they might buy? Now, there's various answers that you could put here, but I'm going to say 6 to 8 pounds. I do not think people will buy much more than that. People will likely not buy any more. Nobody's going to buy a lot more than 6 or 8 pounds of pecans. That's a whole lot of pecans, okay? What is the cost of purchasing 1 pound of pecans? 4.5 pounds. Well, what does it say? It says the cost of purchasing pecans is $3 per pound. So, 1 pound equal to $3. Okay? Then 4.5 pounds. To figure out that, well, if it's $3 for 1 pound, to figure out how many it is for 4.5 pounds, what you want to do is you want to multiply 3 by 4.5. If you multiply those out, you would get $15. Okay? If it's $3 for 1 pound, then it's $6 for 2 pounds. It's $9 for 3 pounds. It's $12 for 4 pounds, you're just multiplying each number of pounds by 3. So an equation that could represent that situation would be y equals 3x. So basically that is what we are going to graph, because the next part says to draw a graph that represents this situation. The reason they ask us about the negative number of pounds and what the maximum number of pounds to graph is so that we can actually do this graph right here. So we're just going to draw the first quadrant. We're just going to draw positive values, because we're not going to have negative pounds, and we're also not going to have negative money, okay? Because it's $3 per pound. So on my x-axis, I've got the number of pounds. On my y-axis, I've got the cost. So that's the number of pounds and then the cost. Then it said the maximum number of pounds that we would probably graph would be 6 to 8. So 1, 2, 3, 4, 5, 6, 7, 8. You could go 9, 10, but people are probably not going to buy 10 pounds. Okay. Then up here, we can go ahead and graph 1, 2, 3, 4. Mark every 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All the way up here is 15. Okay? Now, I know that if I buy 1 pound, that's going to cost me $3. So let's go to 1 pound on the right, and then up to 1, 2, 3. Okay? If I buy 2 pounds, that's going to cost me $6. So that's 5, 6. We can keep going. 3 pounds, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, and then we already graphed, we already figured out in this last part, if we bought 4.5 pounds, that would be equal to $15. So, what we've got right here, this needs to be moved up just a little bit. What we've got right here is 3 different points that we can connect with a straight line. Hopefully yours can be a little straighter than that. But this is the graph that represents this situation. You know, if you buy 0 pounds, that's going to cost you $0. So that should cross that axis right there. So we have a line representing this situation, which we could write as y equals 3x. Okay? The cost per pound data modeled in the graph are continuous. Continuous data are data where numbers between any 2 data values have meaning. So this is a continuous graph. We just graphed a continuous graph. It has no gaps, jumps, or asymptotes. Now, a count of items, such as number of people, that would be a discrete graph. A discrete graph would not be connected like this. We're going to connect a continuous graph. We would not connect a discrete graph. We would leave these 3 dots and not connect them. We will look at that during the lesson practice. That's all for this lesson.